Well, welcome LACCD to Chapter 3 in the Math 115 course that's offered across 4 different colleges. We're going to be going through Chapter 3 and begin to talk about excuse me, the rules working with exponents. And you'll be serve you well to get probably all these done in one place, but we're not going to attack all the rules at any one place here. So there are rules in which if we have certain, it could be a term, it could be just a number, it could be a variable, which are actually all terms, but anything that is raised to an exponent, if we have the same thing that we're working with, raised to an exponent, and well, let's just see how this kind of works here. And for each of these rules, we're going to go ahead and provide some examples for this. You'll get to see this in class as well, but I figure this is as good a place to show it here so that when we talk about these rules in the videos, everyone has an equal footing on this. Okay, so we have rules of exponents or laws of exponents. We have the multiplication rule, such that if we have like a to the x times a to the y, this is a to the x plus y. So let's just kind of give an example of what this looks like over here. So what this is going to look like is I would go ahead and I would take, let's say I have 2 to the third times 2 to the fourth. What I would do then is I would take 2 and I would take the exponents now. Like in this case here, the a is equal to 2 because that's the base. We have an x, that's the first exponent here, that's equal to 3. And we have y, that's equal to 4. So this is going to be 3 plus 4 because it says that we're going to add these bases together here, or add these exponents together here, and that's going to yield for us 2 to the 7th. Another kind of way to consider this rule, and this is not looking at this, this still applies here, is we can write 2 to the third as 2 times 2 times 2. Now a big multiplication sign. So this multiplication sign comes from here. 2 to the fourth, on the other hand, we can write it as 2 times 2 times 2 times 2. So we have 2 times 2 times 2 times 2 times 2 times 2 times 2. We in fact have 2 to the 7th. So we have the 2 being multiplied together here 7 times. So that's why when we have two bases being multiplied that are the same but have various exponents, we go ahead and add the exponents together because the exponent tells us how many times we multiply these together. Okay, I'm going to move this back here and I'll be ready to go to the next explanation of this. Bring this back. We have a division rule. So we have a to the x divided by a to the y. This is going to be equal to a to the x minus y. And we'll go ahead and we'll apply a rule for this, and we'll kind of show an explanation for this as well. So I always try to include an explanation for each rule so that you kind of make some sense of it. So let's say I have 3 to the 10th divided by 3 to the 5th. Now, a lot of times when students would do this, they think because there's division here that they actually have to take these numbers and divide it. But the division sign is not with the exponents. The division sign is with this. So the rule is going to say here that I would take 3 to the 10 minus 5, and that's going to yield for me 3 to the 5th. So that's how we show the work on this one. But let's go ahead and take a look at another example, something where I'm not going to have to write out quite so many numbers. And what I'm going to do is I'm going to have 7 to the 8th divided by 7 squared. Of course, the other way of writing this would be to say, let me see if I can put this down here. This would be like 7 to the 8th divided by 7 to the 2nd. So I put that here not as a cross division, but rather as a fraction written up here. So like the problem I showed above, I'm going to go ahead and I'm going to do this one the long way, and I'm going to write out what 7 to the 8th means. This is repeated multiplication, so I'm going to write this as 7 times 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 7. So I have 7 there being multiplied 8 times. Down here, I'm going to have 7 times 7. So what I find if I do that now is I'm going to end up reducing the number of 7's in the top and bottom by 2, and that leaves me with 7 being multiplied in the numerator 6 times. So all of this is going to equal 7 to the 8 minus 2, which is equal to 7 to the 6th. Hopefully that kind of offers explanation for how that's done. I'm going to put a line through there, and we're going to bring back the rule with another explanation of that, and I'll move it up appropriately here. The next rule we have is a power of a power rule. Kind of, it sounds a little redundant. So we have a to the x, and then this x is raised to the y. And that's going to equal not a to the x plus y, but rather a to the x times y. Students often confuse these two rules about when it's appropriate to add and when it's appropriate to multiply. But let's take a look at the rationale for this third rule coming up here. So let's say we're going to take 2 to the third to the fourth. The rule says we would write this as 2 to the 3 times 4, or get 2 to the 12th. So why is that? So let's go ahead and expand this and look at this a little differently, now without necessarily applying the rule. So if I have 2 to the third to the fourth, what it's saying is that what's being raised to the exponent? 2 to the third. What's the exponent? 4. So that means that, and I'm going to make sure to bring this in a little bit here. Let me line this up here again. So, and make sure that everything is visible. It is. That means that what am I raising to the fourth? What am I multiplying 4 times? I'm multiplying 2 to the third times 2 to the third times 2 to the third times 2 to the third. That's being multiplied 4 times. Once I carry that out, it's 2 to the third times 2 to the third times 2 to the third times 2 to the third. Applying the first rule we learned about a little while ago. By applying the multiplication rule, we should add these exponents now, and that is going to give us equals 2 to the 3 plus 3 plus 3 plus 3, which is going to give us 2 to the 12th. So here's a rule being applied generically. Here's why we apply the rule as such. So I hope that kind of clarifies things here. So I'm going to go ahead and show the power of a product rule next. So that's this rule here. Let me make sure I kind of bring this up so I don't confuse these explanations. All right. So the power of a product rule next. And it says in the power of product rule we have the quantity of a times b raised to the x. Now this is going to be equal to a to the x times b to the x. So let's take a look at what that kind of looks like then. Okay. So let's say we have the term 3 p to the fourth. What this rule says is that this is going to be 3 to the fourth times p to the fourth, because I basically distribute that. Make sure I get this lined up properly right here. Yeah, so I'm applying this rule and showing this explanation. So I'm going to give the a term, like the 3, the exponent of 4, and then I'm going to give the b term, which is p, I'm going to give it that exponent of 4. The reason that is let's take a look at this another way. If I take 3p and I raise this to the fourth, well, what is that? That's going to be 3p times 3p times 3p times 3p, and you'll find that we have the 3 being multiplied together 4 times, and then each p being multiplied together, p to the first times p to the first times p to the first times p to the first. And if I add those, that gives me p to the fourth. And at any time, if I'm moving too fast for any of these, feel free to rewind or kind of start all over again. I'm going to show a few more principles here. And actually, this is going to be the very first video to launch here because people are going to need to see this later, but I'll allude to it from time to time. Next rule. I'll flip my paper over now. Next, what we're going to talk about is what's known as the power of a fraction rule, which we have right here. And we'll see what this looks like now. So we have a divided by b raised to the x on the outside, which is equal to a to the x divided by b to the x. Now, the reason we have this here is because if, let's say, for example, I have 1 over 3, and I have that raised to the third, that's going to be equal to 1 over 3 times 1 over 3 times 1 over 3. Meaning that's going to be equal to 1 to the third divided by 3 to the third. Hence, I just go ahead and I distribute the exponent that's here onto the top term and the bottom term. So this is applying the power of a fraction rule. Next rule we're going to look at, as I bring my paper back out here, is what's called the zero exponent. And I'm going to add one caveat to this, is that it's a to the 0 is equal to 1 so long as a is not equal to 0. So we can't raise 0 to the 0 and have it be equal to 1, but anything else, it's going to equal 1. We'll take a look at why that is in a moment here, but we have to apply the rule from above to do that. So let's go ahead and let's consider we have 2 to the third divided by 2 to the third. Now, if we write it out this way, this would give us 2 times 2 times 2 over 2 times 2 times 2. If you find that we reduce these, everything cancels, leaving us with a 1. However, if, and I'll try to leave this here, let me fold this up a little bit because I'm running out of space. And put this up here. There we go. However, if I carry this out as 2 to the third divided by 2 to the third, that's going to give me 2 to the 3 minus 3, which is going to give me 2 to the 0. And based on what we saw up here, we know that's going to be equal to 1. So any number other than 0 that's raised to the 0 exponent is going to equal to 1. We're going to use this explanation here for something else in a moment. We're going to go ahead and put a line there. And we're going to take a look at another rule that we're going to be using, and that's the negative exponent rule. We're going to come back to this fractional exponent later, so I won't go through this one today. But the negative exponent rule works in the following way. So we have a to the negative x equals 1 over a to the x. Well, this is such strange, because we can have negative exponents. Yes, we can, and we have them. And we're going to be working with them in class. So let's see where negative exponents come from. So let's just take a look at kind of a simpler example, if you will. So let's say I have 2 to the 4th divided by, let's make it 2 to the 5th. 2 to the 5th. 2 to the 5th divided by 2 to the 3rd. I would carry that out. I would get 2 times 2 times 2 times 2 times 2 divided by 2 times 2 times 2. That's going to give me 2 to the 2nd. So I would have that for my final answer there. Now, this is one answer. The way you're supposed to do this usually is if you have 2 to the 5th divided by 2 to the 3rd. You're supposed to do this as 2 to the 5th minus 3, giving us 2 to the 2nd. So this is the long way of doing it. This is the short way of doing it. Let's turn the tables on this, though. So let's say instead, I'm going to move this up a little bit here. Let's say instead we have 2 to the 3rd divided by 2 to the 5th. What does this look like? So what that's going to give us is it's going to give us 2 times 2 times 2 divided by 2 times 2 times 2 times 2 times 2. And if we do that now, we're going to cross out 2 of these 3's. We're going to get 1 over 2 squared. So that's the result we get if we write this out as a fraction. Writing this out lengthwise, we would have 2 to the 3rd. Let me bring this up a little more. 2 to the 3rd divided by 2 to the 5th. The rule tells us this would be 2 to the 3 minus 5. And for that result, we seem to get 2 to the negative 2. So these answers look the same, but in fact, they are identical to each other. Hence why, if we did the same problem and obtained these two answers, we could then therefore say 2 to the negative 2 is going to be equal to 1 over 2 to the second. And one of the rules we're going to learn about later is if we want to get rid of a negative exponent, all we have to do is we can take any expression like 2 to the negative 2 over 1, and we move it to the bottom and just write it as 1 over 2 to the second. By putting it from the top to the bottom, we get rid of the negative on the exponent. So that's the first video that briefly explains these power rules, and keep these kind of things handy as we go through the problems that we're going to be working on in the next set of videos.